to notes on 2.5, the distributive property. So taking notes on line paper is great. I just usually use white paper so that the lines don't mess up your vision, your view of the material during the notes. All right, so this is section 2.5 in your book, if you would like to look at it that way. And so what we're going to be doing here to start off with the distributive property is I'm going to make a rectangle, and we're going to find the area of that rectangle. Okay, but I'm actually going to cut it into two separate parts, and I'm only going to give you measurements for each of those separate pieces. So I'm going to have this kind of be our green section here. All right, and I'm going to have this side of the green guy be 3, and that side be 2. It could be centimeters, inches, whatever you want. And then I'll make this bigger guy orange, and this distance is going to be x. And then I'm going to say, find the area of that rectangle. So first of all, in order to do that, you probably need the formula for area of a rectangle. So I sure hope that's in your brain. Of course it is, right? Yes, yes, it's in your brain. The formula for area of a rectangle is area equals length times width. So we need to know the length and the width, okay? Well, you may or may not know what to do with this length. Clearly the width is 3, but this length has an x and it also has a 2. So if you weren't sure what to do, we could find the area of each one separately and then add them together. So I'm going to do that same thing, what I was just talking about there. I'm going to make them two separate rectangles. So here's my green guy over here, and distance was 3 and 2. And then my orange guy, length was x, and then what's the width? Well, it's the same as that one, right? It's 3. So let's find the area of the orange rectangle first. Area is length times width. The length is x. The width is 3. Well, all I can do is multiply them together, and when we write things together like that, we always have the coefficient come first. The coefficient is the number in front of the variable, so that's the coefficient, he comes first. So we don't write x3, we write 3x. And then our small green guy, area equals length times width. The length is 3, the width is 2. Now, you may want to say, how do I know which one's length and which one's width? Length is always longer than width. It doesn't matter if you're going to say it's the one on the bottom or the one on the side. I'll just turn my paper, and then it's going to be a different top, bottom, right, left. So the area of this guy is 6 units. So if I said, what's the area together for that whole rectangle, you would then have to add these guys together and add 3x plus 6. And that's all you can do unless somebody comes along and says, oh, by the way, x is 7 or something like that. Okay, so we have to leave it like that. Well, what I want to do is I want to show you the distributive property to prove that whether we did the area all together or the area separately, we're going to get 3x plus 6. So back over here on the left, we have, again, area equals length times width. The longer side is x plus 2. It's this whole side here, x plus 2. The shorter side, the width, is 3. And then remember, multiplying is commutative, so I can reorder this so that the 3 comes first, because I can multiply in any order. Well, this is your distributive property. Do you remember it from last year? What I can do is I can multiply the 3 by every item on the inside. 3 times x becomes 3x, because there's like a 1 in front of that x. 3 times 1 is 3, and the x comes along for the ride. The plus sign gets rewritten, and then 3 times 2 is 6. Bingo. What did we get? We got the exact same answer if we did them separately or if we did them together. And that's the point of the distributive property. Okay? All right, the next part I want to show you is that the distributive property also works if you had a subtraction symbol on the inside there. So what if this had been 3 times the quantity of x minus 2? Well, I'm going to distribute. So 3 times x is 3x. The minus sign comes down, and 3 times 2 is 6. If you say to me, but I thought last year they said make minus adding a negative. Okay, make minus adding a negative. So I made it plus a negative 2. Distribute. 3x plus negative 6. Is minus 6 and adding a negative 6 the same thing? It sure is. So it works either way. Okay, I want to show you one more example. What if I stuck a negative in front of the 3 on the outside there, and I made this x minus 2? Okay, now you decide, you want to keep it as a minus sign or plus a negative. I personally want to make it plus a negative, because if I don't, I'm worried I'm going to screw this up because there's a negative guy out here. So I'm going to make that adding a negative 2. And then I'm going to distribute my negative 3. So negative 3 times x is negative 3x. Plus sign comes down. Negative 3 times negative 2 is a positive 6 because a negative times a negative is a positive. Okay, so at this time, I want to direct your attention to page 96 in your book. Page 96 in your book. That's the beginning of the distributor property. And what we were just discussing is right here in your book. Here are the rectangles we just did. It also talks about equivalent expressions. So that's saying 3 times the quantity of x plus 2 is equivalent to 3x plus 3 times 2, or 3x plus 6. They are equivalent expressions. And we use the distributor property to multiply those out. If you look over on page 97 of your book, there are 4 vocab terms there. We're going to talk about all 4 of those vocab terms right now, but if you are having trouble with the meaning, you are going to come back to this page here and look at what the definitions are. Now remember, vocabulary is always in the back of the book and the glossary as well. So if you're not happy with the way they wrote it here, you could look at the glossary in the back. So I'm going to give you an expression. Remember, an expression doesn't have an equal sign or an answer. Okay? So the expression I would like to give you is 5x minus 3 minus 4x plus 12. And I'm going to ask you to identify some things. The first thing I'm going to ask you to identify are the terms of this expression. Then I want you to identify the like terms. Also, the coefficients, and that's a term I mentioned earlier in the notes, and the constants. Okay, so a term is any part of this expression that's separated by operations, okay? But the deal is the minus signs aren't legit. You have to make those adding a negative, because negative 3 is the term here, not 3. Just like 4x is not the term, it's negative 4x. Okay, so when I say write the terms, you're going to say 5x is a term, comma, 3 is a term, negative 3 is a term, negative 4x, and a positive 12. And I just write the terms out separated by commas. Now, like terms. What are some like terms? You did those last year. So 5x has a like term. What term is it like? It's just like negative 4x. And negative 3 is a like term. What is it like? 12. Okay? Now the coefficient, do you remember what I said in the notes? A coefficient is the number in front of a variable. So there are 2 coefficients in this example. It's 5 and negative 4. Those are the numbers in front of the variable. And then lastly, a constant is a number that cannot change, so it doesn't have a variable. There are 2 constants in this as well. It's negative 3 and 12. Those are the constants. Okay, so I'm going to give you an example. We're going to write down this expression. Negative 7x squared plus 2 minus 4x plus 3 minus 5x. Okay? And I want you to write down the terms, the like terms, the coefficients, and the constants. And you are going to pause the video here while you do that. You're not just going to play it and write down whatever I write down. You're going to pause the video and then come back and check and see how you did. Okay, so here's what we got. The terms are all of them. Did you add your adding negatives so that it was a negative 4x and a negative 5x, and you just list them out separated by commas? The like terms, there were just two sets, 2 and 3 are like terms, and negative 4x and negative 5x are like terms. Negative 7x squared is not like anything because x squared is different than x. You can't put them together. And then the coefficients are numbers in front of variables. Negative 7, negative 4, and negative 5 are all in front of variables. The constants are 2 and 3. Okay, so let's do an example of the distributive property, but I'm going to put something else on the outside here. I'm going to put a variable on the outside. All right, so what do we do when we have to multiply variables together? Well, first of all, if that x there is throwing you off in the middle, you can put a 1 in front of him, right? And then what I have to do is, I have to distribute. Well, how do I multiply numbers and variables? The coefficients get multiplied. So 3 times 1 is 3. And then x times x is actually x squared. And we're going to learn a lot more in the future of why that is. But this is actually to the first power and to the first power. And so you have to add those together to make 2. We don't need to worry about that too much right now. You just need to remember that x times x is x squared. And then the plus sign comes down. And then what we have here is 3x times 2. So 3 times 2 gets multiplied. And the x goes along for the ride. So that's what that one would look like. All right, so what I'm going to do here is I'm going to make up some problems. And you are going to solve them all. And you're going to pause the video and see how you did. So number 1, I would like you to simplify these. Let's do negative 2 times the quantity. Well, do negative 2x. Negative 2x times the quantity of x minus 4. Number 2, you're going to do, should I get tricky right away? What do you think? 6 minus 2 times the quantity of 3 squared minus 4. I know, look at this. I went from one extreme to the other. That quantity is cubed plus 7. Woo, baby. All right, we're going to do those two. You pause the video and see how you did. Okay, on the first guy, did you get negative 2x squared? There's like a 1 in front of here, so it's negative 2. X times x is x squared. Plus sign comes down, and I made that negative 4. Negative times negative is a positive, and x goes along for the ride. Number 2, I'm actually going to talk through it. You're going to check your work. This one should already be done. Let's see how you did. So the first thing I'm going to do is order of operations. I have parentheses. In my parentheses, I have a 3 squared. It beats out subtraction. The other thing I'm going to do right now is I'm going to add a negative on these because I think I'm going to need it for this problem. So I rewrite the 6 plus negative 2. 3 times 3 is 9. 9 minus 4 I could have kept here, or plus negative 4 is the same thing. Cubed plus 7. All right, 9 plus negative 4 is 5. Rewriting the rest of the problem each time. Okay. Cubed comes next, so 5 times 5 times 5 is 125. Oh, goodness. Phew. All right, continuing on. Now, see why I needed to make that plus a negative? Because right here, we could have had a potential problem if you didn't distribute the negative. It would have worked out okay in this guy, but in future problems, it could cause a big problem. So, we're multiplying here, and that's a negative 250 plus 7. Now, when I look at this guy, I'm like, oh, man, I got to deal with 6 and then a negative 250, but I'm like, ooh, commutative property of addition. I'm allowed to add in any order. So I'm going to do 6 plus 7 first is 13. If you didn't notice that, you probably used your calculator. That's okay. But then I'm going to add those together to make negative 237. I just try to make my life a little easier each time. All right, so hopefully you were good on that one. I've got 2 more bonus questions for you. We shall see. I know you can do this. So this is number 3. Number 3 is 4 minus the quantity of 2 minus 5 cubed. Okay? Go ahead and pause the video and see if you can do this one. All right, so I'm going to talk through this one. You should have paused it and tried it. Right here, this is probably causing you an issue. What do you do with this minus sign? I'm not going to worry about it right now. I'm going to show you what's going to happen here. I'm going to make that plus a negative. I have 4 minus 2 minus 5, or 2 plus negative 5 is negative 3 cubed. What I want to tell you is what is between this minus sign and that parenthesis? There's actually a 1 there. So if you don't like that minus sign, you could make this plus a negative 1, and you could tell yourself, hey, that's going to get multiplied by negative 1 there. Then it looks a lot like the other problems we were doing. So the 4 plus negative 1 gets rewritten. Negative 3 times negative 3 is a positive 9, times another negative 3 is a negative 27. And then I have a negative times a negative, which is positive 27. So this problem is actually 31. So hopefully you did all right on that guy. Okay? Okay, so what happens now, number 4, when I start adding in variables? 6r minus 2 times the quantity of r plus 4. So I have parentheses, right? But I can't add them together because they're not like terms. So I need to distribute. But I need to distribute not 2. What's being multiplied there? Not 2. It's negative 2. And this is bingo bango. The number 1 mistake we're going to have on the summative assessment is people are going to distribute a 2 there and make a mistake. So this should be 6r plus negative 2 times r is a negative 2r. Plus sign comes down. Negative 2 times 4 is negative 8. And then if I have any like terms, they get to go together. Look at 6r and negative 2r are like terms. They both are r terms. They make 4r. And then plus negative 8 gets added on, and I can't do anything until somebody says, oh, hey, by the way, r is whatever they want to say. Okay? So let me give you one more now. I'm going to kind of combine everything. I know I said we had 2 more, but I got to get one more in here just to make sure you're good. So 6r minus the quantity of r plus 4. So pause that and see if you can do that on your own, and then come back. All right, you should have paused it. Here's what you got to do on this guy. Did you make this plus negative 1 and distribute the negative 1 through? That's what has to happen here. So 6r gets rewritten. Negative 1 times r is a negative, and you can write negative 1r or just r, negative r. And then negative 1 times 4 is negative 4. Add like terms. 6r and negative 1r are 5r. And plus negative 4, or you could write minus 4, just gets rewritten. All right, I gave you some bonus problems there at the end of the notes. Your notes are your problems in the assignment aren't all going to be that hard, but we're definitely going to have problems like that in the future, so I wanted to get them out now. So good job taking notes, and then you're off to your assignment, which is the next day.